Hello, and welcome to I Know Dino, the Big Dinosaur Podcast, where we cover news, interviews, and discussions of all things dinosaur.
Hello and welcome to I Know Dino. I'm Garrett.
And I'm Sabrina.
And today we'll be talking about Allosaurus, as well as a lot of dinosaur news.
We're back from our trip to Europe, where we had the opportunity to see a lot of interesting dinosaur museums. For those of you following us on social media, we posted a few pictures on our Twitter and Facebook feeds.
And this is our 25th episode, which we're recording on Saturday, May 16th. First in the news, there's a new quarry that was discovered in Montana called JRDI 5ES Quarry. I guess it doesn't have a cool name yet. It's just known by that scientific nomenclature. And the unique thing about it is they found a set of Stegosaurus that appear to show differences between the genders. So specifically, the Stegosaurus in this area is called Stegosaurus moose. And if you read it, the moose part is spelled MJOSI. And that's named after the man who collected and prepared the holotype of that species. The study was published in the PLOS One journal, which we've mentioned before, and they're quick to point out that it's very difficult generally to find differences between genders of dinosaurs, especially because there are a lot of differences just between species and within a species. So a lot of times if you're looking at different specimens, especially if they're in different areas, you're not sure if the differences between the specimens is because they're different species or they have some other variation that's not related to their gender. But in this case, they're very confident that based on the way the skeletons were arranged, that each of them are from the same species. And on top of that, they're convinced that the individual plates that they found from the different Stegosaurus match with individual specimens. So what they found was some of the species had larger round plates and other ones had narrower but a little bit taller plates. What you might think if you just found a scattered assortment of those plates is that the round plates came from one part of the back, whereas the tall plates came from another part of the back or something like that. But in this case, they're pretty convinced that they came from different specimens. Based on what we see in modern birds and also a lot of other modern animals, they believe that the specimens with the larger round plates were probably the males because they tend to show off more, and the ones with the thinner but slightly taller plates were probably the females because the males would have to put more effort and energy into displaying, and the larger plates would have taken more energy to grow, so the only reason to really have them would be to attract a mate, if it's only a difference between the two genders. Just to make sure that the plates didn't change throughout the age of the Stegosaurus, they closely looked at all the bones through a CT scan to make sure that the density of the bones and other characteristics were similar so that they could be confident that they came from the similar age Stegosaurus, and they found that they did in fact match, so they believe they were all full-grown adults. It'll be interesting to see what else they can find in this new area in Montana. While we were away, there were two very important discoveries of theropod dinosaurs. The first one we're going to talk about was a discovery out of Chile. This species is called Chilesaurus diegosuarezi, and it's named after the son of the two geologists who discovered the species in the mountains. They didn't just find one specimen, they actually found quite a few, and that's actually very important in this case because the species is pretty unusual. Most interestingly about it is that it's a theropod, but it's also a plant eater. And if you remember from earlier episodes, theropods are the group that include Tyrannosaurus rex and Torvosaurus, and they're typically meat eaters. Scientists had previously thought that later on in the theropod group throughout the years, they did develop and split off a few plant-eating members, but this shows the plant eaters very early in the theropod group. So it really calls into question some of the earlier assumptions, and it's going to take a while for the scientists to reevaluate what the theropod group really was like and what species it may have included. So its upper body is kind of similar to some other theropods, other than the fact that it had teeth obviously designed for chewing on plants, but its hips and its feet have more in common with some other plant-eating dinosaurs. It also had arms and hands that were pretty similar to an Allosaurus, except that rather than having claws, it had 2 stumpy fingers. The juveniles that were discovered were about the size of turkeys, but the adults that they found grew up to 9 feet or 3 meters long. Some researchers are pointing out that this is a good example that you shouldn't just group species together based on appearances alone, even though it's tempting, especially in a case like dinosaurs when we can't see where they lived and the genetic material that shows how they're related. But we're seeing a lot of cases like these where seemingly completely different looking dinosaurs with different traits and different behavior are actually very closely related. The other theropod discovery that happened in the last couple of weeks was out of China, a species called Yi-Chi, spelled Y-I-Q-I. Yi-Chi belongs to the group Scansoriopterigidae, which means climbing wings. Others in this family have been discovered in the past, and they decided that they probably climb trees based on curved claws on their back feet and indications on their hands that looked like they probably climb trees. One indication is the way that their wrists bent in a way that would allow them to fold their wings such that they could still grasp and climb things, but wouldn't be ideal for flight, so it makes the most sense that they would need that to climb, even though it limits their ability to fly. So if you've seen this in the news, you've probably seen it described as a bat-like dinosaur, and in this case I totally agree with them. I think that's the best way to describe it. This species didn't seem to have feathers on its wing itself, but it did have a membrane covering what looked to be a wing. The fossil does show a membrane between basically its fingers, which is known as a patagium. So everything that flies has this membrane, and you typically don't think of it on a bird, you just think of feathers attached to an arm type thing, but there really is a membrane beneath it. It's just so covered in feathers that you don't see it at all. The reason a bat description is good, despite all animals having this membrane, isn't just because it didn't appear to have much for feathers, it's because of what is connected. So the best way to describe a bat is basically a very elongated hand, and there's a web in between the fingers. If you imagine a pterodactyl being just the ring finger with a web connecting the ring finger back to the rest of its body so that all of the force of flying is just on one finger compared with a hand on a bat, and then on a bird, on a modern bird, the wing is basically the entire arm. It connects from the shoulder all the way out to the end of the limb. So obviously the strongest is using a whole arm and the weakest is using just one finger. So this is somewhere in between. But the really weird thing is, before it gets to the hand where it spreads out and turns into a sort of wing, there is a rod sticking out of the wrist, separate from the fingers, and the web was connected through that as well. Now, with the fossil, they can't tell what angle the rod was with relation to the wrist, and it was a pretty long rod. They call it a rod because it's not clear how the bone was formed or if it was a hard cartilage or what it was, but it definitely supported the wing in a similar way to the fingers. If it was at a really steep angle, meaning close to the arm of the animal, it would have made for a really narrow wing, which definitely wouldn't have been good enough to fly for very long distances. It probably would have just glided very short distances. But if the rod stuck at a 90-degree angle out from its arm, it would have given it much more surface area, which would have been a lot better for flying. But we can't tell right now with the specimen that was discovered. Interestingly, since we know that the wrist of this family bent, it probably couldn't have flapped its wings hard enough to really take off from the ground. So it likely climbed trees and maybe flapped while gliding a little bit, but probably couldn't really fly long distances. It was probably more of a glider. Now, it did have some downy feathers around its wings, but it didn't appear to be covered in feathers, and much less feathers that would help in flight. Probably the most interesting thing about this discovery is that it's just another example of flight evolving that didn't end up sticking around to present day. So it's another mechanism that animals had convergent evolution towards flying, but possibly not the best way to make it for the long haul. It may help us understand a little bit more about the origins of flight, however, and it's also interesting because the feathers that it had were not seen on any other flying species before this specimen. If you've got about $2 million to spare, there's a Triceratops skull going on auction in Hong Kong that might be just what you need. It weighs 1,300 pounds. It's almost 10 feet long, over 5 feet high, and about 4.5 feet wide. So it would be a good focal point for any room, I think. I don't really understand who would want to buy this rather than put it in a museum, but nonetheless, there's a constant debate over whether fossils should be privately sold or put in museums. I tend to be on the museum side because you can always get a replica if you're not studying the thing. But anyway, apparently this skull has traded hands quite a few times, and it's been dubbed the Dragon King because it's so huge, and I guess there's a lot of interest in it, which is why they're putting it up for auction. In Jurassic Park news, it appears that the Jurassic World movie is still going to have a few animatronic dinosaurs in it. So the original Jurassic Park had tons of animatronic and puppet dinosaurs, and I've just learned that there's a lot of behind-the-scenes footage of this on YouTube, which is just awesome to watch. There are videos of how they made the T-Rex from concept to final, completely painted and sculpted, massive, full-scale animatronic glory, as well as the people that were inside the velociraptors. Actually, the scene where they're in the kitchen and they're being hunted by the velociraptors, there were people inside those, pretending like they couldn't figure out where the kids were walking around the kitchen, which is just awesome.
Just one quick bit of trivia about the T-Rex. Apparently when they were filming on the island, it rained a bunch of times, and sometimes the animatronic T-Rex seemed to come to life on its own. Like it would make its own sounds, or I think it was mostly the sounds. So at times it seemed like there was really a T-Rex with them.
So when they got to later Jurassic Park movies, like the second and third, there were less and less animatronic dinosaurs. But the creator of Jurassic World has said that there will still be animatronic dinosaurs and people inside them as puppets, and that it won't be just the velociraptors, which is kind of the obvious choice, but he won't say which dinosaur it will be yet. So I believe we've mentioned before the large number of dinosaur tracks near Williston Lake in Canada's British Columbia, but there is a little bit of new news about them. Paleontologist Rich McRae is trying to crowdfund a preservation effort of these fossils, and specifically he wants to make it a tourist site. So right now he's campaigning for $190,000 to get the project started, and he notes that it's one of the biggest dinosaur track sites in Canada, which makes it one of the biggest in the world. Last fall, this area that's called Tumbler Ridge was designated a UNESCO Geopark, which is a designation that recognizes geological heritage. And they converted a school into a dinosaur museum and a place to hold the fossils. So it definitely seems like it's a good option for tourism. Just to be a one-upper, Bolivia found about 5,000 new dinosaur tracks and now has the biggest set of dinosaur tracks in the whole world. The footprints that we're talking about are at a place called Cal Orco, which is near Sucre in Bolivia. And if you know where that is, you know more than I do. But there were already over 5,000 tracks there, So this additional 5,000 puts it over 10,000, and they're along a 1 mile or 1.5 kilometer by 110 meter or about 360 feet high outcrop. And it's at a 75-degree gradient, which means the pictures of it basically look like it's a wall. So there are cool pictures of people walking up to it and basically looking at a wall of dinosaur footprints, which are also in our show notes. So this outcrop is included in a theme park called Cretaceous Park, which gets about 150,000 visitors a year. I know I want to go. And it has footprints from ankylosaurs and theropods and other dinosaurs. And they're also seeking to make it a UNESCO World Heritage Site for its significance. We've talked about the Chicxulub crater before and how that's typically the event that paleontologists point to as the extinction event for the dinosaurs. But we've also mentioned that there's a bit of controversy over whether it was volcanoes, a comet, or other climate change that may have killed off the dinosaurs. So there's a recent study that showed that an impact that would have been big enough to make the crater at Chicxulub could have caused some major volcanic activity. So rather than a combination of volcanoes and meteor strike combining to wipe out the dinosaurs, it may just be that the meteor hit and caused the volcanoes to erupt. The theory is published in the Geological Society of America Bulletin, and they point out that an impact large enough to create the Chicxulub crater would have created about a 9.0 on the Richter scale, and some researchers at UC Berkeley have done research to show that a 9.0 would be enough to cause some significant volcanic activity. Combined with some improved radio dating techniques, it appears that the impact at Chicxulub is within 100,000 years of major volcanic activity at the Deccan Traps. They also found that Deccan lava was chemically different before and after the Chicxulub crater event. So they believe that perhaps it was already erupting, or perhaps there was some magma ready to erupt, and then the impact forced a different kind of magma out. So this could have caused quite a bit of extra pollution into the atmosphere, which could have more negatively affected the dinosaurs than just the impact of the meteor would have by itself. But there are still plenty of scientists pointing out that just because these two events coincided doesn't actually mean that the volcanoes had anything to do with the dinosaurs going extinct. It could just be that that was a side effect of the impact, and whether or not these volcanoes erupted makes no difference. As radio dating techniques get better and we find more discoveries of fossils, we may be able to tell better whether or not these volcanic eruptions had a big impact on the extinction of dinosaurs or whether it was strictly the meteor impact. If you can't wait for Jurassic World to come out, there's another dinosaur movie coming out called Cowboys vs. Dinosaurs. And I guess it's the modern equivalent of straight to VHS because it's apparently going to be on digital HD and on demand, which I think is just a cable thing. I think I've seen on demand on cable boxes before. But it looks super cheesy. And since it's going to be out on May 19th, that means if you're jonesing for some dinosaur cheesy movie, you can look it up. And last but not least, we've got a story about field station dinosaurs in Secaucus, New Jersey. We talked about them earlier and how the animatronic dinosaurs there aren't quite as exciting as some of the other ones we've seen. But it is still a good place to take kids, and there are some good events going on there. Unfortunately, it's going to close after this season, and that's as a result of building a new school in the area. So, it's still progress. At least they're not building like a shopping mall or something. They actually knew that a school was going to get built there when they opened the park as a dinosaur amusement park, which is why they only got a 3-year lease when they opened it, and it's been renewed a couple years after that. But they're finally ready to build the school, so it's time for the dinosaurs to move out. They are going to add one last exhibit before moving out, which is going to coincide with the Jurassic World movie, and it's going to be all about how dinosaurs may have sounded. I'm not sure exactly how they're going to figure that out, but it would be interesting to see. They might just talk about how dinosaur sounds are created for the movie, like we talked about the whales and other crazy stuff that go into the T-Rex noise that everybody's familiar with. They have done a good job of updating the signs when new discoveries like the fact that Brontosaurus is its own genera came about, and they added clarifications to the signage. And some of the streets around it are named after dinosaurs, so it will be interesting to see if when the school opens, if they leave them those names or not.
And that's all we have for news for this episode. Now on to our dinosaur of the day, which is Allosaurus, and was requested by Facebook fan Tori, so thanks Tori. Allosaurus' name means different reptile, and it got its name because its vertebrae was different from other dinosaurs. There are 3 widely accepted species of Allosaurus, including fragilis, maximus, and jimmadseni. And we'll be focusing on Allosaurus fragilis today, but there might be other species of Allosaurus. This includes amplexus, atrox, europaeus, and tendagurensis. So there's a lot of variation between some of these species and very little variation between others, so not everyone accepts that all of these are different Allosaurus species. Over a 30-year time span, 8 different species of Allosaurus have been proposed, so again, it's not completely clear how many there are, but 3 are widely accepted. The most common Allosaurus species is Allosaurus fragilis, at least 60 specimens that have been found. But there have been a lot of dinosaurs mistakenly classified as allosaurs or part of the Allosauridae family, and there's a whole long laundry list. And one of the reasons that there was all this confusion is that Charles Marsh, when he found the holotype Allosaurus, it was an incomplete specimen. And even though his rival Edward Cope had found a well-preserved Allosaurus specimen just 2 years after him, these later Allosaurus discoveries were compared to Marsh's incomplete skeleton.
Because that partial skeleton is still the holotype, and to this day it still causes a little bit of confusion, there have been some scientists who want a neotype of Allosaurus to be declared. It would be a little bit unusual because a neotype is usually only called for when the original holotype is destroyed, lost, or when the author never names one, but in this case it might be useful just to make it really clear what an Allosaurus is rather than just identifying it by a few bones.
So again, Charles Marsh formally named Allosaurus fragilis in 1877, and Allosaurus was one of the earliest dinosaur discoveries. It was discovered during Marsh and Cope's Bone Wars, which again is why some of the Allosaurus specimens may have been classified as a different species in their haste to name as many dinosaurs as possible. They may have had some inaccuracies. There's one pretty complete skeleton of Allosaurus found in 1883 in Colorado by a rancher named M.P. Felch, and H.F. Hubble found a more complete Allosaurus skeleton in 1879, but it wasn't examined until 1903 after he died. A man named Ferdinand Van Peer Hayden first described Allosaurus in 1869 as having a petrified horse hoof. However, this hoof was actually a tailbone, which Joseph Leidy classified to the genus Antrodemus. Allosaurus fossils from all ages have been found, so they found eggs all the way up through adult specimens.
Compared to its hind legs, Allosaurus did have relatively short arms, but compared to other theropods like T-Rex, it had pretty substantial arms. They had 3 large claws on each hand, and they were underneath the claw was a dew claw. If you have a cat, you might be familiar with dew claws. It's basically a bone that's underneath a sheath. So we actually have a cast replica of a Allosaurus hand, which is really cool. And the claws look huge, but it's actually just the bone part. The actual sheath that went over it, like a fingernail type thing, would have been much bigger. And because of that, a lot of researchers think that they probably used their hands for grabbing prey. It's not conclusive that they would have done this, but since they had such formidable claws, it's likely that they would have used their hands rather than just biting at prey like something like T-Rex would have done.
So if you ever go to Dinosaur National Monument, which if you get the chance you should, because it's a really great place to visit, you can see 2 different species of Allosaurus. There's Allosaurus fragilis and Allosaurus Jimmadseni. Jimmadseni is more rare. Actually, only one half of a jimmadseni skull has been found so far, and it was separated along the midline, so you can see the left half. And the Allosaurus jimmadseni specimen in Dinosaur National Park is a very complete specimen and even has the wishbone in place. The other species, Allosaurus fragilis, was one of the largest predators in the Morrison Formation, and it had teeth up to 3 inches long and could grow to 30 feet in length, which is about 10 meters. And at Dinosaur National Monument, the Allosaurus fragilis skeleton has one of the best preserved skulls, which is rare because it has a thin bone that can be easily crushed. Fragilis had a disproportionately large skull, like other large theropods, and it had bony ridges like blunted horns over its eyes that was covered in a keratin sheath, which may have been used to attract mates. It weighed about 3 tons, and it used its serrated teeth to cut through flesh. And it had binocular vision, but was limited to 20 degrees, so it would have to see prey directly in front of it. Otherwise, if the prey turned quickly, Allosaurus would only be able to use one eye to see the prey, would not have depth perception. So it could turn its head, but timing was a big factor in a successful attack. A 2013 biomechanical study by Eric Snively and his colleagues found that Allosaurus had a low attachment point on the skull. This means it can make quick, forceful vertical movements with its skull, similar to falcons, where they grip prey with their skull and feet, then pull up quickly to remove the flesh. And Allosaurus could probably move its head and neck quickly and with a lot of control. Going back to its teeth, it probably lost its teeth easily while feeding and could quickly replace them. Its lower and upper jaw had 14 to 17 teeth, and it had bones at the tip of its snout. This is called the premaxilla, that had 5 teeth. Allosaurus was bipedal, and it had a long tail to help counterbalance its head with its S-curved neck. Like other theropods, Allosaurus had bird-like features, such as air sacs in its neck vertebrae and a wishbone. Its brain was similar to crocodiles, and it had large olfactory bulbs but an underdeveloped area for assessing, which means that it might have only recognized a few smells, like for prey or for its own kind. It did have a high EQ, which means fairly large brain to body weight ratio, and so it was very intelligent, especially compared to other dinosaurs of its time. And it could hear low frequency sounds. One kind of strange thing about Allosaurus is it had a gastrolium. This is a hanging belly ribs that are thinner than upper ribs and support and protect internal organs such as lungs. They may have aided in breathing. They're not attached to the backbone like in a human's ribs, but they are formed from the skin in the middle region of the body, so they are referred to as dermal bones. Young allosaurs had proportionately longer legs than adult allosaurs, so adults matured to have shorter muscular legs, probably to protect it from injury when tackling larger prey, but the younger allosaurs were quicker and better adapted to catching small, quick prey. As adults, they may not have been very fast due to their short arms that couldn't help break their fall. But in 1998, Dr. Bruce Rothschild from the Arthritis Center of Northeast Ohio found evidence of 14 fractured ribs in an Allosaurus that it probably got from falling, so it may have belly flopped while running. And an X-ray analysis of the Allosaurus found that the ribs had cracked and healed, so Allosaurus probably could handle a lot of injuries from running. Allosaurus was smaller and lighter than T-Rex, so in a race it probably would win. And there's estimates of top speeds ranging between 19 and 34 miles per hour. Allosaurus fossils have been found all over, including in the states Montana, Wyoming, South Dakota, Colorado, Oklahoma, New Mexico, and Utah, and it's actually the official state fossil of Utah. About 75% of all carnivorous dinosaurs found in the Morrison Formation are Allosaurus. In the Cleveland Lloyd Quarry in Utah, which has over 10,000 dinosaur bones, most of them are Allosaurus.
Since the Cleveland Lloyd Quarry is in Utah, it shouldn't be too much of a surprise that the Natural History Museum of Utah has a big exhibit on it. And it's one of the best mysterious archaeological demonstrations that I've ever seen. Basically, underneath the floor when you're standing at the exhibit of the museum, they have the bones laid out in a crazy arrangement. And then they have a couple of videos playing where they talk about different theories that scientists have of how the bones may have gotten there and why there are so many Allosaurus in one spot. There are so many theories because there is a really high density of Allosaurus fossils in that area, and they seem all jumbled up. So a couple of the theories that I remember was there was this bloat and float, they called it, theory. And the idea was that a bunch of dinosaurs died in a river, and then they got all filled with gas when they started decomposing, and then they floated down a river and eventually settled down. By that point, all of their bones had kind of scattered. And then there was another one where maybe there was like a quicksand or muddy quagmire situation where there were some dead or dying dinosaurs which attracted a bunch of allosaurs, and then more and more of them kept getting stuck when they were coming to try to eat the other ones. But they're all very interesting theories, and obviously no one has figured out what exactly happened. So if you're interested in Allosaurus or that type of a mystery, you should definitely go to that museum and see that exhibit.
It's a fun one. I think they present it as a murder mystery. So Allosaurus was a common predator of its time in North America in the late Jurassic, and it lived alongside Apatosaurus, Diplodocus, Camarasaurus, Stegosaurus, and Camptosaurus. Allosaurus was probably an active hunter. While its bite was probably weaker than alligators, lions, and leopards, it may have used its skull as a hatchet, so it could slam its upper jaw onto prey and then tear out the flesh with its teeth. This is according to a 2001 study in Nature Journal. It probably preyed on stegosaurs and iguanodonts, and there is one famous allosaur specimen found with a Stegosaurus pubis injury. This particular Allosaurus got into a fight with a Stegosaurus and died from a wound from a deep stab of a Stegosaurus tail to its pubis. So Stegosaurus could jab its tail like a sword instead of swinging side to side. There's no locking joints, so it moved like a monkey's tail. And it probably penetrated the Allosaurus bone, and then the wound was probably fatally infected. This is based on a 2005 paper in the Carnivorous Dinosaurs from Indiana University Press. There's also been evidence of an Allosaurus bite mark on a Stegosaurus plate. And in 1914, C.W. Gilmore described 3 Stegosaurus tail spikes that broke, which may mean it had hit dinosaurs hard enough to break its spikes. Of course, Stegosaurs weren't the only dinosaurs Allosaurus fought. There's tooth marks found on an Apatosaurus vertebrae. And, of course, Allosaurus also shared an area with Ceratops and Torvosaurus, which are other theropods. So they may have gotten into some fights. Allosaurus could open its jaws very wide because it was double hinged, and it could have probably grazed flesh, which may be one way it could have attacked these large sauropods and eat part of them without actually killing them. Allosaurus hunted by overpowering prey, and they may have hunted in small groups so that they could take down large sauropods like Brachiosaurus. They would definitely not have been able to do it alone. However, there's actually not much evidence of gregarious behavior. Instead, it's mostly antagonistic towards each other. There's a lot of injuries and bite wounds to skulls. Maybe Allosaurus was trying to establish dominance in a pack or settle some sort of territory dispute. So they may have been too aggressive to hunt in packs. Also, modern carnivores such as lizards, crocodiles, birds rarely work together, and they're often territorial and kill intruders, even if it's of the same species. So Allosaurus may have attacked its own kind for rights to feed, or for mating rights, or maybe a potential mate didn't want the attention.
As a counterpoint, some other scientists think that Allosaurus may have hunted with mobbing behavior and basically tried to scare one animal out of a herd and then tried to tire it out by chasing it around and then finally killed it and eaten it as a group. But neither of these theories have been confirmed.
True, but scientists think that juvenile allosaurs may have formed their own packs and avoided adults until they became adults themselves, which might help show how they are usually antagonistic towards each other. They probably reached adult size at age 15 and lived up to age 28, according to a 2006 study in the Journal of Morphology. One of the most famous allosaurs is known as Big Al, who lived a very hard life. Had 19 deformities from disease and injury, though most of them healed. But even if all of them had healed, Al would not have been able to live to be that old. Big Al was discovered in 1991. Scientists found 95% of this juvenile specimen. It was 26 feet long. And BBC made a documentary about Al called The Ballad of Big Al. Big Al weighed more than 3.3 tons. It was discovered in Wyoming, but again, He had damage to his ribs, his toe bones, and vertebrae, as well as a bone infection known as osteomyelitis. This is when microorganisms infected the bone, which was damaged in a way that caused it to break and was attacked by the dinosaur's immune system. And as a result, Big Al had misshapen bones. He also had an infection that probably lasted up to 6 months, so poor Al definitely had a hard life. In 1996, the same team who discovered Big Al found Big Al 2, and Big Al 2 is the best preserved skeleton of its kind so far.
The way Big Al may have gotten so big is that Allosaurus seemed to have grown about 330 pounds a year, which could get you to 3 tons in not too much time.
If you want to see some Allosaurus fossils for yourself, you're in luck, because Allosaurus fossils, there may be more of them than any other type of large theropod, so they're found in museums all over the world. Again, you can find some at the Dinosaur National Monument, and at the Dinosaur National Monument you can see a real Allosaurus fragilis skull at the Quarry Exhibit Hall. And you can also see an Allosaurus fragilis specimen at the Carnegie Museum of Natural History in Pittsburgh, Pennsylvania.
We also saw a few replicas of Allosaurus when we were going through Europe, because they're so ubiquitous and interesting looking that they seem to just be all over the place.
Allosaurus is part of the Allosauridae family, which is part of the group Carnosauria. Marsh named the family in 1878, but the name wasn't really used until the 1970s. Instead, the term Megalosauridae was more often used, but it became the quote-unquote wastebasket taxon. Before 1976, most publications referred to Allosaurus as Antrodemus, which is a species that Joseph Leidy discovered in 1870. But in 1920, Charles W. Gilmore found that Antrodemus's tail vertebrae was the same as that of Allosaurus, and said that Allosaurus should be changed to Antrodemus because it was named first. But then in 1976, James Madsen published his monograph and said that the name Allosaurus should be used because Antrodemus was based on poor quality findings with not many diagnostic features or even any information on the geological formation where the one Antrodemus bone came from. Again, this is the bone that was described as hoof-like, but it was actually a tail vertebrae. So the Allosaurus monograph is basically a series of studies of Allosaurus. And Madsen's monograph led to a whole bunch more studies on Allosaurus, which is probably why one of the species is named after him. Allosaurids were medium to large-size carnivorous dinosaurs, and they were great hunters. Most Upper Jurassic and Lower Cretaceous carnivores are somewhat closely related to Allosaurus.
And our fun fact of the day is that it appears that the first flowering plants showed up in the Triassic period, and in that same period we also saw the first flying vertebrates.
And that wraps up this episode of I Know Dino. Thanks for listening, and until next time.
Thank you for listening to I Know Dino. If you have any questions or comments about dinosaurs, we'd like to hear from you at plesiosaur at iknowdino.com. And for more information on dinosaurs, go to iknowdino.com or follow us on Google, Facebook, Tumblr, or Twitter at I Know Dino.